This lesson covers two competencies: illustrate secants, tangents, segments, and sectors of a circle, and prove theorems on secants, tangents, and segments. Actually, we will not be proving the theorems, but instead we will just explain the theorems and give examples. First, we are going to define an inscribed angle. An inscribed angle in a circle is an angle whose vertex is on the circle and whose sides are chords of the circle. So in our illustration here, angle ABC, this angle is an inscribed angle. Another term that we are going to define here is tangent. A tangent to a circle is a line coplanar to the circle that intersects the circle at exactly one point. This point is called the point of tangency. In our illustration, line L is tangent to circle O, and this point A is called the point of tangency. Now let's define a secant line. A secant line is a line that intersects the circle at 2 points. So in our illustration, line AB intersects circle O at points A and B. So line AB is a secant line. Now let's discuss the inscribed angle theorem. So it states that the measure of the inscribed angle is 1/2 the measure of its intercepted arc. So in our illustration, the measure of angle ABC equals 1/2 the measure of arc AC. So suppose this arc AC measures 50 degrees, that means the measure of angle ABC is 1/2 of 50 degrees, which is 25 degrees. Now, let's discuss inscribed angles in the same arc theorem. So it states that two or more angles inscribed in the same arc are congruent. In our illustration, angle ABC is an inscribed angle of arc AC, and also angle ADC is an inscribed angle of arc AC. So these two angles, angle ABC and angle ADC, are congruent. If this angle is 25 degrees, this angle also is 25 degrees. Next, let's discuss the semicircle theorem. Any angle inscribed in a semicircle is a right angle. So in this case, this is a diameter, line segment BC. So this angle BAC is inscribed in a semicircle. So this means angle BAC is a right angle. And also angle BDC, this angle is also inscribed in a semicircle. So this is also a right angle. So this means angle BAC measures 90 degrees and also angle BDC measures 90 degrees. Here is another theorem. If two arcs of a circle are included between parallel secants, then the arcs are congruent. So here we have two parallel secants. We have here secant AB and secant CD. Since the two secants are parallel, that means arc AC is congruent to arc BD. Another theorem states that opposite angles of an inscribed quadrilateral are supplementary. So we have here an inscribed quadrilateral A, B, D, C. Now, angle A and angle D are opposite angles, so they are supplementary. That means angle A plus angle D equals 180 degrees. And also, angle B and angle C are opposite angles, so they are supplementary. That means angle B plus angle C equals 180 degrees. We have another theorem. This is the Intersecting Secants-Interior Theorem. The measure of the angle formed by two secants that intersect in the exterior of the circle is 1/2 the difference of the measures of the intercepted arcs. So we have here two secants intersecting at point E. So this angle E, equals 1/2 the measure of the difference between arc AC and arc BD. So for example, if arc AC measures 80 degrees and arc BD measures 20 degrees, using this formula, we have the measure of angle E equals 1/2 of the difference between 80 degrees and 20 degrees. And then 80 minus 20 is 60, and 1/2 of 60 is 30 degrees. So this means this angle here measures 30 degrees. We have another theorem, the Intersecting Secants-Interior Theorem. The theorem states that the measure of the angle formed by two secants that intersect in the interior of the circle is 1/2 the sum of the measures of the intercepted arcs. So we have here two secants intersecting in the interior of the circle. So the measure of angle BID, this angle here, is 1/2 of the sum of arc AC and arc BD. So for example, if arc AC measures 55 degrees and arc BD measures 35 degrees, using this formula, that means measure of angle BID is 1/2 of the sum of 55 and 35. And 55 plus 35 is 90, and 1/2 of 90 is 45. So this means this angle here measures 45 degrees. We have another theorem. The measure of the angle formed by a tangent and a secant that intersect in the exterior of the circle is 1/2 the difference of the measures of the intercepted arcs. So we have here a secant and a tangent, and they intersect at point D. Now, this means that the measure of this angle here, angle BDC, is 1/2 the difference of the measures of arc AC and arc BC. For example, if arc AC measures 100 degrees and arc BC measures 40 degrees, using our formula, the measure of angle BDC equals 1/2 of the difference between 100 and 40. So 100 minus 40 is 60, and 1/2 of that is 30. So this means this angle here measures 30 degrees. We have another theorem. The measure of the angle formed by two tangents to the same circle is 1/2 the difference of the measures of the intercepted arcs. So this theorem means that the measure of this angle here, angle ABC, this angle, equals 1/2 of the difference between the measure of arc ADC and arc AC. For example, if the measure of arc ADC is 220, this means the measure of arc AC equals 360 minus 220, which is equal to 140. Now, using our formula, the measure of angle ABC is 1/2 of the difference between 220 and 140. And 220 minus 140 is 80, and 1/2 of that is 40. So this means angle ABC measures 40 degrees. We have another theorem. The measure of the angle formed by a secant and a tangent intersecting at the point of tangency is 1/2 the measure of the intercepted arc. We have here the secant and we have here the tangent intersecting at the point of tangency. So that means the measure of angle ABC, this angle, equals 1/2 of the measure of arc AB. So, for example, if the measure of arc AB is 120 degrees, this means the measure of angle ABC is 1/2 of 120 degrees, which is 60 degrees. So this angle measures 60 degrees. Thanks for watching, guys. This is Teacher Regil. Keep safe.